ago that I was approached by a group of scientists in Grenoble looking at making the next generation telecommunication devices. And they were looking to replace silicon devices with silicate glass materials because they were far cheaper, easier to make. But you needed to get a performance of being able to take a signal and process that signal through a medium. Now, typically in silicon wafers and things, that's a difficult and expensive thing to do. It translates onto things like computing, where you have great heat raised in the silicon wafers when you try to increase the speed, because that's electronics. And what happens in electronics, you have electron transfer through a medium. It causes friction. The quicker you drive it, that generates heat, and heat becomes the limiting factor. Hence, if you open your PC, you'll find there's a great big fan on top of the processor and a cooler that takes the heat away from that, and that limits the speed that it can run at. If you look at photonics, the use of photons rather than electrons to drive similar systems, then you enter an entirely different sphere of what is possible using materials like glass. Some crystals work, but glass is a more ubiquitous material in that you can build a vast array of compositions that will allow you to fine-tune what you want to get out of it. So you can build lasers, you can build photonic devices. And what this company in Grenoble were doing is trying to revolutionise the mobile phone market by making it easier and cheaper to produce circuitry. And they were simply infusing silver ions into the surface of simple glasses to allow circuitry to be developed. Beam splitters initially, and then moving on to more complex things like triode valve, diode and triode valves, and then transistors. So it must be more than a dozen years ago that we built the first rudimentary light-powered photonic computer. Now, you're not going to get your Microsofts and whatever, and Intels and all of the people in that environment instantly moving in that direction, because they've spent so long investing in the products that they currently have. But mark my words, 10 years down the line, when these things are phased out, the next generation of photonic materials will be those that are driving what we're seeing in America at the moment, the scrabble around for rare earth materials to control exactly what I'm talking about, the electronics market. And a lot of that is founded in the materials, the transistor type materials that are made in glassy matrices from those products. So again, in that environment, we will find that as knowledge expands, the impact of glass on the electronics as we've known it, but photonics as we will become to know it, market, in terms of things that we use in our everyday lives, will work quicker, cleaner. The ability to reach massive speeds in computing and solve problems, supercomputers, all of this will be powered by glass.